This technical grower talk is about best potting practices. Best potting practices, that means everything a grower needs to do before and during and after potting to make sure that he optimizes the characteristics of the growing media in his containers. So a grower can get a lot of advantages from optimizing his potting practices. Berger's products are manufactured to benefit growers, but they need to be handled properly in order to maximize results. So the following information can help growers improve their potting practices and get the most out of Berger products. So basically, Berger creates the physical and chemical characteristics inside the bale, but it's the grower's responsibility to manage the structure in the containers. So important factors to consider: storage of the actual material, growing media handling, compaction, and adjusting the water content before potting. What can a grower do to improve on storage? Well, first and foremost, obviously rotating your inventory is always ideal. So first in, first out. If products are stored for a long time, it's important to test the wettability before potting. If necessary, you can add a wetting agent to improve on that wettability. The wetting agent is basically the first thing to degrade during storage, especially if it's stored under a high heat environment. So another point for storage is to, if possible, store in a cool area, out of direct sunlight as much as possible. As I mentioned, wetting agents become less efficient when exposed to heat. Another tip that can be interesting for people who are storing, especially out in the colder environments in the winter, you can use 2x4s underneath your pallets to make it easier to actually pick up those pallets, especially if they've been out on dirt or muddy surface. If they're set in the, let's say in autumn and it freezes, it might be hard to pick those up unless they're stored on 2x4s. If possible, maintain a small buffer zone between the skids. This just helps with air circulation between the skids and prevents anything like, for instance, on skyscrapers, if they're stuck together and they're in high heat and you're removing them, the plastics might actually stick together and tear. Berger's traceability system can actually help growers track and manage their products properly in the yard. So each one of our bales, our bags, or our skyscrapers are properly identified with all the information needed to optimize product rotation. Growing media handling is very important. The machinery that you use to decompress your bales or your skyscrapers can have a huge impact on the physical characteristics of your product. So you want to adjust your potting machinery properly to reduce substrate recirculation to a minimum. Also, the fluffing machinery that you use or that you purchase to actually decompress or fluff your skyscrapers should be done carefully. And we have people at Berger that can help you select the correct machinery. Also, the actual machinery that is used to recirculate your substrate should be selected carefully as well. I would prefer that customers use anything that's not an auger. So if they can use a conveyor to actually bring back any excess substrate back into their hopper, it actually reduces the wear and tear that it does on the growing media. Why is it important? Well, our goal at Berger is really to provide a consistent particle size that allows growers to obtain predictable results in the greenhouse in terms of porosity, or at least aeration and water retention inside their containers. So if they're damaging the growing media during the potting procedures, or if they have excessive material that's recirculating, it's going to have an effect on the particle size, which in turn will have an effect on the pore space. As an example, if we look at a given product, let's say a BM6, which would have on an average 30% particles that are retained on the number 10 sieve, if the machinery is doing a lot of damage to the product, we can end up at 25% in the hopper, whereas if we have a machinery that's doing less damage to the product, to our growing media, we could actually reduce that impact by 3%, being at 28% on the number 10 sieve. Now, if we have recirculation equipment that's doing a lot of damage, like an auger, we can actually go down from 25% to 20%. Whereas if we have just a simple conveyor that's doing minimal damage, we can actually reduce that to just 1%. So starting with a 30% particle size product, we can end up at 20% with the handling, whereas if we reduce that handling or make it have as little impact to the product, we can just have a 3% impact. Compaction is really another thing you want to avoid when you're actually filling your containers. If you have a compacted product, oxygen is less available to the plant in the root system. RHP, which is the quality certifying body in Europe, actually did a huge campaign on compaction in Europe a couple of years ago, where what they were basically saying, which is what I'm saying here, is that the more compaction in your container, yes, the more water and nutrient retention you're going to get, but also the less oxygen is going to come back to your growing media, which is not good for root development. So there are different ways you can avoid or reduce compaction in your containers. First of all, during your filling process, for instance, if you're just doing a light fill and brush with little compaction, as an example, you could have 9% airspace in your container. If you take that container and you actually tap it twice, you're actually maybe reducing that airspace by 5%. If you were to actually compact that growing media in the container afterwards, you would actually end up with an airspace of 2%. So from 9% to 2%, that's a huge difference. So what you want to do is when you're potting, you want to reduce that compaction in the growing media. Another source of compaction is pre-filling pots. If you pre-fill your containers and you don't store them properly, you can increase compaction and actually create some inconsistencies. This is an example of pre-filled pots, pre-filled trays where you actually have some nesting here, where you see the cavities are nesting into the cavities below. Another example here as well, you have actually below these containers you have the bottom of the trays that's nesting in the other ones, and you can actually see the effect right here of the trays that were on top, which were compressing the ones below. So what that does in terms of airspace is these containers at the bottom obviously have a lot more weight compressing on them from all the trays that are stacked on top of them. So once you bring those trays out into the greenhouse, well, these trays which are on top, which may have 16% airspace, will end up having a completely different characteristics than these trays that are at the bottom. So these ones will retain water for a lot longer than these ones. So that creates a lot of inconsistent growing in your greenhouse, which every grower really wants to avoid. So what you want to do if you're pre-filling is you want to stack those trays properly, trays or containers. This is an example of offsetting the trays where you're actually not having the cavities nesting into each other. For containers, you can actually use rigid material to actually place between your different levels of pots. Here they actually used flat trays, but you can actually use large pieces of cardboard that lay on the rims of your pots and will actually prevent the pot that's on top from compacting the one that's in the bottom. One thing that we promote at Berger is adjusting your water content prior to potting. There are many reasons that adjusting that water content will be an advantage to the grower. At Berger, we sell our products at a lower water content to basically optimize shipping and actually increase the amount of volume that we put on a truckload. So to adjust the water content, we actually promote maybe not the right word, but we recommend that growers add approximately half a gallon of water per cubic foot of our growing media, and that applies to most of our growing media. There are certain exceptions like our bark mixes and our BM8 compost mix where you would add a little bit less water because the growing media is already at a higher water content. But for most of our products, half a gallon per cubic foot is basically a good starting point. Here's an example of how precise we can be with the water content of our growing media. As I said, the target we're aiming for is 43 to 46%. And over the years, we've done a lot of testing with our competitors, with products from our competitors to evaluate different characteristics of their growing media, including water content. And one of the reasons why we can give such a precise recommendation in terms of adjusting the water content prior to potting is the fact that we keep such a tight window for our water content, whereas we can see here from the results from our competitors, there's a lot more variation, so it's harder for them to give basically a good recommendation as to how much water to add to bring that to the ideal water content for potting, which is between 55 and 65%. As I was mentioning earlier, the goal of having it at 43 to 46% water content is really to optimize or maximize the amount of material we put on a truckload. Just to give you a point of reference, if we were to increase our water content from 43 to 48%, that would mean that we would have to remove a complete skyscraper from a truckload just because of the added weight. Now, the other advantages to adding water prior to potting, well, first of all, you will increase your yield. Having our growing media at 43 to 46%, there's a lot of potential for that growing media to expand in volume. Peat moss is like a sponge, so if you add water to it, it will expand in volume. So you can get approximately, depending on the growing media that you're using, you can increase your yield from 10 to 15% by hydrating the growing media prior to potting. Another great thing about adding water is it will reduce the presence of dust. The smaller, finer particles will actually cluster together to form aggregates. So that actually creates a cleaner environment for the workers. It will also increase the porosity in your containers. Both the swollen peat fibers and the aggregates I was talking about earlier from the finer material aggregating together basically contribute to optimize the soil structure and maximize the porosity in containers. As an example, if we were to fill out a container where the material was dry versus filling out a container with a moistened substrate, once you add the water to the container afterwards, well, if the fibers weren't completely expanded before potting, they'll expand in the container, which will reduce your pore space. Whereas if you've already expanded the growing media before potting, that structure is basically set in stone and it shouldn't change after you've irrigated. Another advantage is really the water distribution. We add a wetting agent to our growing media to help with that water distribution, but what also helps out even more is pre-moistening your growing media. Peat moss is a product that is hydrophobic, so it repels water, but that's when it's dry. Once it's hydrated above 55%, that hydrophobicity really is greatly reduced and the water distribution improves a lot. So the higher content will reduce that surface tension on the peat fibers, and the peat fibers will take up the water much more easily. And what this does is it actually helps reduce channeling, which we see an example of here, which is really what you don't want when you're filling out your containers, putting it out in the greenhouse. You want that water to distribute properly throughout the growing media and not do any of this channeling, because at that point you're really just utilizing a very small fraction of your growing media and your plants will definitely struggle. So Berger puts a lot of effort into manufacturing and providing high quality products for our customers. Proper management of that growing media before, during, and after container filling is really critical to maintaining these attributes during production and to optimize the root environment.